Springfield. What'd you say? So there's a place in Springfield called Springfield Gorge. And that is like a place where you can go rock climb, like outside.
So that's a real place.
Yes.
I went like the show Springfield, like where.
Oh yeah, no Springfield. So actually, the joke with The Simpsons is that you don't know what state they live in.
Yeah.
There are two actual Springfields. There's a Springfield, Ohio, and a Springfield, Illinois. I want to say. So I went to Springfield, Ohio, and went rock climbing. Whereas, like in The Simpsons, wait, you went to Springfield to go rock climbing?
I went rock climbing.
Oh, nice. Did you go to VA? Did you go to VA? Oh, I love the Audubon. We almost went down there, but then we figured the Audubon was going to be super busy. I have my own slash. Yeah. All right. Now. Check what's in the jar. Otherwise, get in the closet behind the calculators, and there's like a minute. There's a lot. I wanted to say million, but I don't want to use hyperbole numbers. Gabe, grab a card. All right. Anyone want to read? Always. Help us out.
Do I just read like the questions too?
Yeah, the paragraph through the questions.
Just like decades and never every 10 years, a decimal number is a number that can be written as a fraction of the denominator. It's a power of 10, 100, 1,000, etc. Because our entire number system is based on 10 decimals are very important and they are everywhere. Much of the math you see in science class usually decimals. Of course, you also use them whenever you work with math. Today you will practice working with decimals using what you know about fractions to make sense of the standard algorithms to multiply decimals. As you look at the keep these questions in mind. How are these decimals like fractions? What does place value have to do with our answer? Does our answer make sense?
Wonderful. So, often, and we as Americans are really bad at this, we just like use words and don't necessarily know what they mean. Has anyone thought about why the word decimal is the word decimal? So, I never really did, like, especially when I was a kid. Dec, right? Especially decky, D-E-C-I. That means we're breaking things up by tenths. Because our entire number system is based on tenths. Now, unfortunately, our temperature system, not based on tens. Our clock system, not based on tens. Our calendar system, not based on tens. Our unit of lengths, in America, not based on tens. So, like, we've messed a lot of things up because, you know, math makes sense, and based on tens makes sense, and divide by 10 makes sense, and then we take everything another direction. Now, there's reasons for some of those things, right? There's 365 days in a year, and there's only so many hours in a day, but still, I can still be annoyed by that.
That's not completely true either. I mean, you can say that there's one zibba-dibba.
Right. So we.
This would be right.
So is your argument like we could restructure time to be base 10?
Yeah, I mean, as long as it will fit in that time span.
Yeah.
We could do it.
Yeah, so take whatever the day is and break it up differently. Because all we have to do is start with one day, right? There's just sun and not sun. Huh? How many seconds? It'd be 3,600 times 24, whatever that giant number is. I doubt it. I doubt it breaks up that nicely. But this is a conversation for another time. We're going too deep. So, I don't like making resource pages for you guys because I don't like running copies because it's a waste of paper when it's really going to be used once and then thrown away. So, I don't have the resource page for you guys. That's intentional. I think we can do this without the resource page. So, you go to the sporting goods store, or Howard goes, and the sign says, all sporting goods, 1/10 off. So, he looks at a pair of rollerblades, rollerblade laces for 40 cents, wanted to find out how much he would save. So, don't follow what the book says. We could shade in a hundredths grid, and shade in 40 of them, right, for 40 cents. And then if we wanted to take a tenth of those off, if we look at rows, right, we could have 10 rows because we have 10 columns, 10 rows. Right now we're using 4 columns, but we're still using all 10 rows. So to take a tenth off, we could shade a tenth the other direction. Say, okay, well, that's a tenth of what we're talking about. And how many cents would he take off? 4, right? So we take off that tenth, and he saves 4 cents, and his final purchase price is 36 cents. Any questions on that? I didn't feel like we needed to use a resource page and things like that. All right, so try this with your group. This is a bit harder. So while also at the sporting goods store, we'll do this. Howard found some new running shoes advertised to weigh 70% of the old version, right? Runners want their shoes to be light. I have a lot of thoughts in my head. Runners want their shoes to be light. So his old shoes weighed 0.8 of a kilogram. Use the problems below to determine how much the new shoes weigh, or do whatever method you want. So with your group, figure out what would the new shoes weigh. How do we figure that out? The new shoes are 70% of the old ones. Take a couple minutes.
Question D is kind of funny in my opinion. By the way, the sub left a great note. Said you guys are working awesome the whole time, so thank you. I appreciate that. Any issues from the lesson that you guys worked on Friday? Kind of. What? Do you remember what? I can pull it back up if you want to talk about something.
I'll freeze this for a moment. OP, do you remember? It's up on the T. Oh, crap, I didn't mean to unfreeze that. OP, if you look up here, do you remember which one was like problematic potentially? There wasn't actually a whole lot in that lesson. If the new shoes are 70% of the old shoes, what percent are we missing? What percent are we missing? 30, right? Because 100% is the whole of everything. So I can either solve for 70% or I could solve for 30%, right? Either way I can get to my answer. So if we use the hundredths grid, or if we just visualize this in our head, right? 8 tenths of a kilogram. Okay, so I have 8 of those columns, right, out of the 10. 8 of those. And I'm going to miss 3 of the rows. Well, if there were 8 columns, 3 rows, how many squares would there be in the section that we're going to take away, or the section that we're going to be missing on the new shoes? We had 8 times 3. You might be visualizing this differently. We can also just do the math, but we don't want to just do it. So if we use the hundredths grid, right, we'd have 8 rows shaded. And then if we look at 30%, we take away 3 of these. In this region that we're removing, there'd be 24. right? 8, 16, 24, 8 times 3. Or, in your head, you looked at what is the remaining region, what's 8 times 7? 56. Now, I like to ignore decimal values or decimal places while I'm doing the math, and then bring them back in to make sure that we did it right. If the shoes did weigh 0.8, and the new ones are 70%, let's jump to D. Are the new ones going to weigh more or less than the old ones? They're going to weigh less, right? They're better. They're lighter. So our new shoes, 0.56 kilograms. So whereas we got 56 boxes, those are hundredths, right? If we had the resource page, but kind of against printing things that don't need printing. Any questions on that? Now the old way that we would tell you to do that, set up 0.70 times 0.8 and do that whole, like, you can do that, that's fine. And you'll still get 0.56. My whole goal as a teacher is make your life easier, right? The easiest way to do any math is break up the hard stuff and make it easier, right? I mean, that's not anything like prolific. I'm not giving you anything worthwhile. But the easiest way to do multiplication, especially, is break numbers at their changing values. Break tens apart from ones. Break hundreds off of tens, and especially break at the decimal point. So if you were given 2.3 times 1.4, go ahead and write on your paper, 2.3 times 1.4. I just about could guarantee that you can't do that quickly. Right? I don't think any of us could argue that we could do that quickly. And even if we take the decimal places out, and I ask you to do 23 times 14, I doubt you could do that quickly. However, what's 2 times 1? 2. What's 3 times 1? 3. What's 2 times 4? 20. Some people need to wake up. What's 3 times 4? 12. Sorry, take a moment, draw this rectangle on your paper. Make it, well, it could be a square, but they have it as a rectangle. The bottom right box is small intentionally. So if you want to draw this accurately, you're trying to show that 2 is bigger than 0.3 and 1 is bigger than 0.4. Like, that's why they have it sized differently. How many decimal places did I have involved in the multiplication that landed me here? 2. You might want to look before you answer. Here, how many decimal places did I have involved? Did I have any decimal places over here? Yeah, I just had 1, right? Only from the 0.3. So I need 1 decimal place in my answer. So it's 0.3. How many decimal places did I have involved in this multiplication? 1. So I need 1 decimal place. Just the 8. How many decimal places did I have involved making this? 2. So I need 2 decimal places making that 0.12. Now, put it back together. 0.3 and 0.8 are going to make 1.1. And then 0.12 more, I believe 3.22.
Yep.
That's how you can make complicated multiplication much easier. Challenge. I gotta switch screens. I hate when I do that. I just wish there was a quick way to have like blank on my screen aside from switching these. Like a blank sheet. I'm gonna go blank. Let's try this out. I don't know. 7.6 times 5.4. Try that using your rectangle method. Guys, take it from someone who's done a lot of math in my life. This really will change how much effort you have to put into thinking. Forget the decimal places to begin with. 7 times 5, 5 times 6, 7 times 4, 4 times 6. Just do the straight multiplication. Then bring your decimal places back. How many decimal places do I need in my top right? 1. How many decimal places do I need down here? 1. How many decimal places do I need over here? 2. And put it together. Fine.
I got 5.04.
5.04?
I think, I forgot to add those 35.
Food 1.04.
41 and 400. I just made that up. I just 7654. I was counting down. Just made that up. Like, so you can do this with anything. Now, this really, because you don't often multiply numbers like this out in the real world, this really comes in handy. I'm trying to use numbers that are different than last time. 72 times 36, right? Some weird multiplication you've been asked to do. You don't have to write this down, but I'm just trying to convince you of how worthwhile this is. 7 times 3. 7 times 3. 21. How many zeros? 2 times 3. How many zeros? 7 times 6. How many zeros? 2 times 6. How many zeros? None. Put them together. There's. That's why we're doing this. Now, to take it one step further, that'll blow your mind, and like, hope you don't care about this, but you will care eventually. Sorry, that's an X also. Just right? We don't know what either of those numbers are. We don't know what X is. We don't know what 7X minus 4 is. We don't know what 2X plus 2 is. But I can tell you what the product is. I shouldn't have done 2 and 2. Sorry. Two times 7 is 14. X times X is X squared. Right? 2 times 7 is 14. X, there's no more X's, just one X. Boom. Boom. Put it all together. Positive 6. That's it. Any amount of numbers, any amount of digits, any amount of decimals, all we have to do is split it up where things change. This split is between unknown value and known value, right? This is variable term, this is constant term, two different things. That's where our split comes there, as opposed to hundreds and tens. And so this skill is going to keep coming around in CPM. Okay, this is the level that my high school math 2 kids are at. Like, to be able to quickly do those things. Like, we shouldn't have to spend time on that, but that's high school math 2. Right, so this is where this is going to come back around. If nobody's explained this to you, CPM is a cyclical-based textbook, which means you learn stuff in 7th grade, then you learn stuff in 8th grade, and you keep coming back around the same material, but you're going deeper and deeper in the content. So like all the stuff we do this year, fine, great, awesome, it's low level. But then you go into 8th grade, and literally like, we take a few laps this year. Like you're going to see the same stuff over and over again, but we keep getting deeper and deeper and deeper. Yeah, which is good for your learning. It's really effective.
Just drill down.
Yeah. Well, I don't like the word drill. Yeah, if you think of it like that, you can. Let's look at this situation. Jody goofed up. Or sorry, Judy. Dang it, Judy. So, here's her work for 2.3 times 1.4. Right? She's old school. She's like your mom or your aunt or somebody, and she's trying to tell you that you have to stack the multiplication. And you're like, no, but we have this rectangle. And she's like, crazy hippie school, don't use a rectangle. So, seriously, your parents and other people that you talk to who learn math the old way, they're immediately going to tell you stack the decimals on top of each other and multiply the old way. So Judy does it, right? And she gets 92 and 230. Dang it, Judy. So what's going on here? Is she right? Like 4 times 3 makes 12. We put the 1 on top. 4 times 2, 8. Add the 1. You got the 9's right. The 0 drops down. 1 times 3, yeah. 1 times 2, yeah. What's she missing? Decimals. So how do we know where to put them? Do you know? You can take however many places are in the top and then put them in the bottom. If everything's lined up right, if we've dropped the zeros correctly, if we've done the multiplication correctly, if... Don't do it the old way. My advice, now I'm not like, nothing in this class is ever like the end all be all, the only right way. But like my best advice to you, break your numbers up, use the rectangle type multiplication, use that strategy whether or not you realize that it's way easier. It's the same exact thing as what we did here, guys. Same thing. Just these numbers in our rectangle are broken up a bit more. They're broken into the multiple regions as opposed to being compressed and kind of presented together. So my best advice, avoid the old school multiplication. Try this. I'm not even going to give you advice before you dive in. Try this multiplication. 3/10 times 16/100. Wow, my Zoom is really particular right now. I don't have advice for you on how to break this up. This doesn't really work very well now, right? The box. Because this only has one place value, right? 3/10. Is this true? Just making sure I'm not breaking any rules. Like that's still the same thing.
Yeah.
What would you get?
You would have to you haven't done and
What would you get if you did 3 times 10? 30, right? But this isn't 3 times 10. It's 0.3 times 0.1. So 3 times 10 gives me 30, but how many decimal places were involved? If I'm using 0.3 and 0.10, if I'm keeping that 0, somebody can check it. What's a tenth of 3/10 is 3/100. Now, this 0 is really unnecessary. So is this 0? So if we do that, what's 3 times 1? 3, but how many decimal places are involved? 2 still bumps us over. What's 3 times 6? 18, but how many decimal places involved? 3. We got to use 3 decimal places. And I can add those up. No calculator needed. Because I guarantee y'all have memorized up to 9 times 9. Right? Your single digit multiplication. I sure hope you've gotten pretty decent at that. And if not, you can use your fingers, right? It's okay. I still do that. If it's an even number, you better believe I'm doubling like until I get there. Break up your processes. Okay, we're taking kind of what I feel like is a long time to talk about just better strategies. But the big picture here is if you have a better strategy for what you're trying to accomplish, it totally changes the amount of effort that you have to put in. All right, try these out. 69 right here. A doesn't even really have any breaking up to do. We just did this, but what's 3 times 6? 18. But how many decimal places? 2. When there's 1 negative involved, is our answer going to be positive or negative? Negative. What's 4 times 5? 20, but how many decimal places? 2. What's 2 times 7? 14. What's a negative times a negative? Positive. How many decimal places? 2. So we use both of our digits in the decimal. Questions? Yeah.
What is the meaning of 5?
42. Try 70, and then we'll probably just take some time for homework here in a minute. Check his work. So, I think Jerry set this up, and Ron does it a different way. We have 2 different answers here. We have negative 12.72 and negative 8.48. With your group, figure out who's right and why. Take your cards. So we check the rectangle. Ask yourself, is it broken up correctly? Then we check inside the rectangle, is the multiplication done correctly? Can anyone spot the error? Mallory?
5 times 0.4.
What do you mean? How so? Okay, I still don't understand. Wendell?
That's a negative number.
That's a negative. A negative 2.4. Sorry, Quinn, go ahead.
Forgot to add a negative sign to
That's negative. Because it's part of the negative. So this is also negative. Now, who's right? Ah, thank you, Savannah. This is also negative. Every single thing here is negative. Because these are negatives, these are positives. Every square here only involves one negative and one positive. So this is our correct answer. Be really careful if you start using the breakup technique with negative numbers. You really got to keep track of where those negatives go. Yeah.
I just think it a bit easy. If it's the same number, but same two numbers, one's a negative, it's going to be the same answer, but it's negative.
Yeah. Start your homework. I like to give you guys time for homework. I don't think we need to run these last couple questions. Just go ahead and dive into that homework. You didn't write it down in your playbook when you walked in? I'll put it back up. So specifically, 73 to 77? Not sure. Yeah, just hang on to it for now. Probably end of the chapter, maybe. I need to do some catching up from being out Friday.
You're so grounded.
Barbie. I mean, what? Hurricane Irma. You need to start living life.
gotta get more comfortable doing math with each other.
No, don't let's be so
Who here would rather do math alone as opposed to with other people? Oh, good. We need to brainwash you guys. Seriously, math is easier if you do it with other people, at least just to like verify your answers.
I learn better on my own.
No.
You think you learn better on your own. All right, sorry. I'll give you your next. I'll give you the last 6 minutes to be awkward, silent little robots.
Yes, I was like quiet and I like it. Also, I like to talk